Hello guys and welcome to my channel. In this session, I want to talk about implementation process. Well, if you want to find out more about this process, then don't miss this training session. And as always, have a good one. The purpose of the implementation process is to realize a specified system element. The implementation process creates or fabricates a system element conforming to that element's detailed description, for example, requirements, architecture, design, including interfaces. The element is constructed employing appropriate technology and industry practices. During the implementation process, engineers follow the requirements allocated to the system element to fabricate, code, or build each individual element using specified materials, processes, physical or logical arrangements, standards, technologies, and or information flows outlined in detailed drawings or other design documentation. System requirements are verified and stakeholder requirements are validated. If subsequent configuration audits reveal discrepancies, recursive interactions occur with predecessor activities or processes as required to correct them. Here we have the IPO diagram for the implementation process. Implementation process activities begin with detailed design and include the following. Prepare for implementation. Define fabrication or coding procedures, tools, and equipment to be used, implementation tolerances, and the means and criteria for auditing configuration of resulting elements to the detailed design documentation. In the case of repeated system element implementations, such as for mass manufacturing or replacement elements, the implementation strategy is defined or refined to achieve consistent and repeatable element production and retained in the project decision database for future use. Elicit from stakeholders, developers, and teammates any constraints imposed by implementation technology, a strategy, or implementation enabling systems. Record the constraints for consideration in the definition of the requirements, architecture, and design. Document the plan for acquiring or gaining access to resources needed during implementation. The planning includes the identification of requirements and interfaces for the enabling system. Perform implementation. Develop data for training users on correct and safe procedures for operating and maintaining that element, either as a standalone and item or as part of a larger system. Complete detailed product, process, material specification, for example, build to or code to documents, and corresponding analysis. Ensure the realization of the system elements per the detailed product, process, and material specification, and produce documented evidence of implementation compliance. Specifically, these tasks are as follows. 1. Conduct peer reviews and testing. Inspect and verify software for correct functionality, white box testing, etc., in accordance with software or hardware best practices. 2. Conduct hardware conformation audits. Compare hardware elements to detailed drawings to ensure that each element meets its detailed specifications prior to integration with other elements. Prepare initial training capability and draft training documentation to be used to provide the user community with the ability to operate, conduct failure detection and isolation, conduct contingency scenarios, and maintain the system as appropriate. Prepare a hazardous material log if applicable. Determine the packaging and storage requirements for the system element and ensure initiation of the packaging and or storage at the appropriate time. Manage results of implementation. Identify and record implementation results. Maintain the records per organizational policy. Record any anomalies encountered during the implementation process and analyze and resolve the anomalies. For example, corrective actions or improvements using the quality assurance process. Establish and maintain traceability of the implemented system elements with the system architecture, design, and system and interface requirements that are needed for implementation. Provide baseline information for configuration management. Here are some of the usual common approaches and tips. Keep the Integrated Product Development Team or IPDT engaged to assist with configuration issues and redesign. Inspections are a proactive way to build in quality. In anticipation of improving process control, reducing production inspections, and lowering maintenance activities, many manufacturing firms use Design for Six Sigma or lean manufacturing. Conduct hardware confirmation audits or system element level hardware verification. Ensure sufficient software unit verification prior to integration. And finally, validate simulations. Interface simulator drivers should be representative of tactical environments. The implementation process typically focuses on the following four forms of system elements: hardware or physical. Output is fabricated or adapted hardware or physical element. If the hardware element is being reused, it may require modification. Software. Output is software code and executable images. Operational resources. Output includes procedures and training. These are verified to the system requirements and OPSCON. Services. Output includes specified services. These may be result of one or more hardware, software, or operational elements resulting in the service. The implementation process can support either the creation or fabrication or development or adaptation of system elements. For system elements that are reused or acquired, such as COTS, the implementation process allows for adaptation of the elements to satisfy the needs of the SOI. This is usually accomplished via configuration settings provided with the element, for example, hardware configuration switches and software configuration tables. Newly created products have more flexibility to be designed and developed to meet the needs of the SOI without modification.